Okay, so welcome to 5.2 part 1. So 5.2 is a section in the book um, that is now about the graphs of sine and cosine waves. So 5.2 is graphs of sine and cosine. So the first thing that we want to look at with these graphs is, first of all, we want to notice that sine and cosine, and in fact tangent and secant and cosecant, those are all periodic functions. All of the trigonometric functions are periodic functions. A periodic function, we've already talked about this just a little bit on Monday, but a periodic function, more fully, is defined as a function f is called periodic if there is a positive p such that, and then there's this little equation, so it is that f of x plus p is equal to f of x for all x in the domain of f. So what this means here is that if I take a function and I add a little bit to it, then it should give me the same thing as if I hadn't added that little bit to it. But that little bit is specific. It can't just be any random little bit. So sine and cosine work because our bit right there, our p that we're looking at, would be 2 pi. That would be the same thing as using 2 pi. So if you take any angle and then you add 2 pi to it with your sine function, with just a general sine function, you get the same thing as if you hadn't added the 2 pi to it. So I'll take a look at that in just a second. I'm going to finish out this definition. So there's another added on part, and it is that if p is the smallest such number, for which the equation holds, this equation that's right up here, for which the equation holds, then p is called the fundamental period. Okay, so fundamental period, that is the smallest version of p that you could find. So let's go ahead and take a look at that example, and that'll make a little bit more sense. So my example is the function f of x is equal to sine of x. Now notice we normally use theta inside of our sine function. I'm putting x in there. It's the same thing, it's just a different variable. The x will make sense when you go to graph it on a Cartesian plane because you use your x and your y, not your theta and your y. And so I'm going to use x in this section. All right, so f of x equals sine of x is a periodic function. And I know that because if I were to choose f of, I don't know, pi halves, then that would be the same as the value I would get if I used f of pi halves plus 2 pi. So if I were to stick f of pi halves, so if I were to stick in sine of pi halves, then that would be the same thing that I would get if I were to stick in sine of pi halves plus 2 pi. These two equations would give me the same exact thing. And so this is what we call a periodic function. And its fundamental period would be 2 pi. So 2 pi is the smallest value that I could use that is going to give me the same number back. Because notice up here, I can also say that this is the same as sine of pi over 2 plus 4 pi. I can add on 4 pi and it gives me the same thing, go twice around the circle. Or I could use 6 pi, I could go 3 times around the circle. I could just keep going and going, and no matter what, if I always add on just another time around that circle, another 2 pi, then I'm going to get the same thing as if I hadn't had that 2 pi in there. And so our fundamental period is 2 pi. You could also have said that its period is 4 pi or 6 pi or 8 pi or 8,000 pi. All of those would be correct statements, but its smallest period is this 2 pi. And so that's how that guy works.